this kind of number in its denary equivalent, what we can do is that you draw the table with, you see the number has 8 digits, so you draw a table with 8 columns. So you can come here, then draw a table with 8 columns like that. So you put this number in those values. So you start with the, you can put it here 0, then 1, alafu 0 1, then 0 0 1 1, like that. So you put these numbers in that table, each digit taking its column, and then you come back and put the values of 2. So we have 2, these numbers are in the powers of 2, so you put like that, but each number has its place value. So the first one here, it is 2 raised to power 0. You start from the right hand side, you start with 2 raised to power 0. So you write 2 raised to power 0 like that. The second one, you increment, it will be 2 raised to power 1 like that. And then the next one is 2 raised to power 2. So you go like that in powers of 2, starting from power 0, power 2, power 3, power 4, then power 5, then power 6, then power 7, like that. So once you have that, you can also add another row below this one so that you simplify the powers of 2. So you can insert another row and another row below it, so that we have the simplified versions of 2 raised to power 2, so that we know 2 raised to power 2 is equal to what. So here 2 raised to power 0, any number raised to power 0 is equal to, the answer is 2 raised to power 0,
0 1 1 1,
it is 1. Then 2 raised to power 1, any number raised to power 1 is equal to that number. So 2 raised to power 1 is equal to 1, is equal to 2. 2 raised to power 2 is like 2 squared. You are multiplying 2 by 2, so it is 4. 2 raised to power 3, 2 raised to power 3 means 2 times 3, 2 times 2 times 2 times 2, so you get 8. You are multiplying 2 3 times. 2 raised to power 4, it is 2 times 2 times 2 times 2, you get 16. 2 raised to power 5 is 2 times 2 times 2 times 2 times 2 times 2, you get 32. 2 raised to power 6, it is 2 times 2 6 times, so you get 64. And 2 raised to power 7, you multiply 2 times itself 7 times, you get 128, like that. So we have simplified, this is equal to this, so whatever is in the first row is equal to whatever is below it, like that. This one is equal to this, this one is equal to this, and so on. So next step is to add another row below this one here, where we will put our answers, and our answers will come from multiplication. So you multiply whatever is at the second row and whatever is at the third row. So whatever is here and here, you multiply and write the answer here. So for example, you start 1 times 1, what do you get? 1 times 1, you get 1. Are you there, Alan?
yes,
Yes, I hope you are observing. 1 times 1, you get 1. 2 times 1, you get, what do you get?
2,
You get 2. Then 4 times 0, you get
2,
0. 8 times 0, you get it is still 0. 8 times 0, it is 0. 16 times 1, it is 16. 32 times 0, 32 times 0,
0.
it is 0. Then 64 times 1,
0.
64 times 1, 64.
1.
At 1.
1. Oh, 54.
Wewe unalala bado wewe. 128 times 0.
64.
Okay, tuko hapa 128 times 64. Sorry. 128 times 0. 128 times 0. Napata nini? Pata 0. So what you do now, unachukua hizi za chini.
0.
Yes, hizi za chini sasa you add the ones that are at the bottom. So this is what you add. Sorry. So for you to add the numbers at the bottom, you take you can ignore the ones with zeros and take the ones with the higher values like this one. So you can just take 64 plus 16 plus 2 plus 1, like that. You can choose to ignore the ones with zeros because they will make no difference. Then once you add this 64 plus 16, that is 80. Is it 80? Yeah. Then plus 3, that is 83. So the answer here is 83 in denary or in decimal. So basically that's how you do the conversion from binary to denary. Okay, I hope you got it. Hii umepata?
Yeah.
Okay, wacha tufanye moja ya convert from...
Yes, sir.
Sorry, umepata? Now let's do one for converting from denary to binary. The opposite of what we've done. Converting from denary to binary. Now, let me add another blank page here so that we can work. So we want to convert 213 to its binary equivalent. So we want to do the opposite of what we've been doing, and for this one you also just draw the table, and the table should have, let's say, 3 columns. So 3 rows plus about 8 columns. 1 2 3 4 5 6 7. So you can add another column here so that we have 8 columns. Insert to the right. So we have this number. We want to convert it to binary equivalent. So what you do, you begin by writing the powers of 2. So you start with 2 raised to power 7, and you move to 2 raised to power 6. Okay, it is always good to start with this one, this side, 2 raised to power 0, like that. It's always good to start from the right hand side, moving back to the left hand side. So you begin 2 raised to power 0, 2 raised to power 1, then 2 raised to power 2, then 2 raised to power 3, then you move to 2 raised to power 4, then 2 raised to power 5, and finally 2 raised to power 6, then 2 raised to power 7. So it is always good to have like that. So you write it like this, and then once you've written it like this, you simplify to get the equivalent of this. You start with 2 raised to power 0, which is equal to 1. 2 raised to power 1 is equal to 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. And this one is 16. This one is 32. This is 64. And this is 128. So you write it like that. And then, now what you will be doing, you will be looking at your number here, this number, and then comparing it with these values here. So you start with the right hand side, you start from here. So you take 213 and then compare to 128. Is 213 greater than 128? 213 and 128, which one is greater? Hello? Hello?
213 is greater than 128.
Yeah, this one 213 is greater than 128. So this one is greater than this one. So if it is greater than that one, you write a 1. If it is less than that, you write a 0. So because 213 is greater than 128, you write 1 there to show that it is greater than 128. And then next step is for you to take 213 minus 128. So you get your calculator, and that's why you need a calculator. I don't know if you are allowed to use calculators in exam rooms, but you can even do that mathematics just using a rough paper. So you take 213 minus 128, and the answer that remains is 85. So you take 85, let's have it 85 here, it is what remains. You take it and compare it to this second value, 64. Is 85 greater than 64?
Yes.
Yes, it is. So if it is greater than 64,
Yes.
if it is greater than 64, you write 1. If it is not, you write 0. But because it is greater than 64, we write 1. And then we take 64 minus 80. 84 minus 64. Sorry, 85 minus 64. I think we remain with that is 1, 2. It should be 21. Yeah, 21 is the remainder. Okay, when you minus this one, you get 21 as the remainder. So you take this 21 and compare it with the third value here. Is 21 greater than 32? Is 21 greater than 32? Alan?
Less. It's less than 32.
Yeah, it is less than 32. So if it is less than 32,
Yes.
you write 0 to show that it is not
It
greater
is less than 32.
Yes, so you write 0 for that matter. Okay, and then once you write 0, you don't do any subtractions. You just take the same 21 and compare it to the next value. Okay, and ask, is 21 greater than 16?
Yes, it's greater than 16.
Yes, so you write 1 like that, and then now you come and subtract 16 from here, and when you subtract 16, you get 5. Okay, then now you take this 5 and ask, is 5 greater than 8? 5 is not greater than 8, so you write a 0. Then you take the same 5 and ask, is 5 greater than 4? Yes, 5 is greater than 4, so you write 1. Okay, and then now you take 5 minus 4
Yes.
to get 1. Are we together? Then once you get 1, you
Yes.
take this 1 and ask, is 1 greater than 2? No, 1 is not greater than 2, so it is 0. And then you take the same 1, is this 1 greater than 1 that is here? It is not greater than, but it is equal to. If it is equal to that value, you write 1, so it is 1. So basically that's how you do the conversion, and the value that you get here is the correct answer. So all this was the rough work. You can clear it, or you can leave it you can do it somewhere else, but these values that we get here is the binary equivalent of 213. So this is the answer. Sijui kama umeelewa hiyo.
Yeah.
Okay, tunaweza jaribu ingine pia yenye we can try another one to convert to binary. Let's use okay, let's have this one, convert 188 to its binary equivalent. So we can convert this one to its binary equivalent. The first step, I said that you draw the table with the binary values, and the table should have 8 columns. So you ensure that the table has 8 columns, and then you start with your powers of 2, 2, 2, 2, 2, 2. Then the first one here is 2 raised to power 0. The next one here is 2 raised to power 1, and this one is 2 raised to power 2, and this is 2 raised to power 3. This is 2 raised to power 4. This is 2 raised to power 5, and this is 2 raised to power 6, and finally we have 2 raised to power 7. So you write those powers like that, then you can simplify the powers of 2 and say that this is 2 raised to power 0, it is 1. 2 raised to power 1 is
1.
2. 2 raised to power 2 is 4. This is 8. This is 16. This is 32. And this is 6, 4. And finally it is 128, like that. Then so then you can add another row below. So you insert a row below whereby we will be doing your comparison. So our value that we are comparing is 188. This is the number, the equation that we want to convert. So the first thing is for you to ask, is 188 greater than 128? 188 greater than 128?
188 is
It is
greater than 128.
Yes, exactly. It is greater than that. So if it is greater than that or equal to that, you write 1, and then you take 188 minus 128. I think you should get about 50. 188 minus 128, it should be 50. Oh, it is 60. Yeah, so our answer is 60. And then you take this answer, yeah, this remainder, and compare with the second item here. So is 60 greater than 64? 60 is not greater than 64. Okay,
It is less than.
it is less than, so we write 0, and then we still have 60, and we take that 60, compare with 32. Is 60 greater than 32? Yes, it is. So you write 1, and you come and say 60
Yes.
minus 32. You should get 28, but we can confirm. Minus 32 should be 28. So
Yes.
the remainder is 28. So you take this remainder, compare with 16 here, and say, is 28 greater than 16? Yes, it is greater than 16. So we write 1.
Yes.
And then you take 28 minus 16. The answer should be 12. Huh? Yeah. And then you compare this 12 with 8. Is 12 greater than 8? Yes, it is greater than 8. So you write 1. And then you take 12 minus 8, which is 4. The remainder is 4. You take this remainder and ask, is 4 greater than 4 or equal to 4? It is not greater than 4, but it is equal to 4. So for that matter, because it is equal to 4, we write 1. If it is greater than or equal to that number, we write 1. And then when we minus, we get 0. 4 minus 4, we get 0. We get 0. So we ask, is 0 greater than 2? No, it is not. So you write 0. And then the same 0 greater than 1, it is not greater than 1. So you write 0. So the value that you get here is the answer for that question. So you can, this was the rough work. So the answer is 1 0 1 1 1 1 0 0 in binary. You can have a space to separate the two nibbles like that. So this is the answer for that question. I hope hizo mbili zimetosha. I'll give you an assignment to do that. Takutumia kwa WhatsApp assignment on that. Kwa sawa? Okay. Maybe kesho tunaweza angalia how to convert two's complement. Vitu zinaitwa two's complement tunaweza zifanya kesho ama usiku. Nitaona kama tutapata time ya usiku, or we can do it tomorrow. But wacha tufanye binary addition kidogo kabla tumalize. Sawa sawa? Yeah, binary addition. Yeah, so you can be given some values. For example, 1 0 0, a number like this one. Then you told to add another number like 0 0 1 0 1. Yeah, unapewa hizi numbers, unaambiwa you add. So what you do, you need to arrange them in a grid so that zikuwe line moja. So you can take this one. Let me take this one here. Evo. Then you can add this one. So yeah, and can increase the font kidogo ndio ionekane vizuri. So for you to add this, niweke some spaces so that the place values can be clearly seen like that. You ensure that the place values are matching so that confuse. So here you adding this one, the 0 plus 1. Are we together? Let me push it to the next page. Page break, yeah. So we adding 0. We start from the left hand side vile tunafanyanga mathematics ya kawaida. So it is 0 plus 1. 0 plus 1 you get a 0. A 0 like that. Acha niandike hapo. Then 1 plus 1, or let me put this in a table so that zionekane vizuri, zinachanganya kidogo. Let me put them in a table with 8 columns. Left. So let me copy this one in a table. Okay, 1 0 1 1 0 0 1 0. Then I can have another. Let me insert another. Insert below another row. Let me clear this. So this one is 0 0. But in your exam you don't need to draw the table for this one. You can just calculate as long as you arrange the values correctly. 0 0, then 1. So here you will be adding 1 plus 0, you get 1. Here you also add 1 plus 0, you get 1. Here you add 0 plus 0, you get 0. 1 plus 0 plus 1, it is 1. 1 plus 0, it is 1. 1 plus 1, 1 plus 1 is 1. It is not 0, or it is not 2. 1 plus 1 is 1. So you write 1 and then you carry 1. Hiyo 1 yenye una carry unakuja unaongeza hapa. So there is a 1 that you will add here. Okay? And that 1, you take that 1 that you've carried plus 0 and you get 1. And then 1 plus 0, you get 1, like that. So this third row is the answer for our question. Hii ndio jibu. Sawa. Okay, let me clear this and then we have another one. Let's have other values here to add. So let's say we are adding 1 0 0 1 1 0 1. Yeah, we are adding that to 0 1 1 0, like that. Okay, yeah. So we are adding these two values together. We can have, let me add another column, another row above, so that it is for the carry bit. It is what we call the carry bit that you carry. So you take this. Let me take the first one number 0 0 0, then 1 1, then 0 and 1. We are adding to this 1 1 0 1 0 1 and 0. So we want to add these two numbers, okay? And this one, this row here will be holding our carrier bits, the one that we carry the excess, so that we add to the next place value. So you start with 1 plus 0, you get 1. There is no carry bit there. 0 plus 1, you get 1. 1 plus 1, you get 1. You get 0 carry 1. 1 plus 1 is 0 carry 1. Are we together?
Yes.
yeah, 1 plus 1 you get 0, you carry 1, then the one that you carry you come and add to this one. So you take the 1 plus 1 plus 0, so it is also 0, and you carry 1. And then you take 1 plus 0 plus 1, it is also 0, carry 1. And then it is now 1 plus 0 plus 0, this one is 1, carry nothing. And then this is 0 plus 1, it is 1. 1 plus 0, it is 1. So this is the answer for that operation. So kutakuwa na some carry bits, you just carry alafu unaongeza. Whenever you have 1 plus 1, it is 0, you carry 1. Zikiwa 1s tatu, for example 1 plus 1 plus 1, it is 1, carry 1. Sawa sawa?
Yes.
Yes. So I think that you can try that, and acha nikutumia hizi kazi on WhatsApp so that you try on your own, alafu pia ukimaliza unaweza nitumia tu kwa WhatsApp. Sawa sawa? Then we meet tomorrow. Otherwise I want to wish you a good day.
Thank you.
Okay, bye.